reporting category 5 is about properties of square root functions. And we don't have a whole lot of vocabulary to do for square root functions, because in this category there's things like domain and range and solving equations, and we've talked about domain and range a bunch, so I don't think we need to do that again. Square root equations, you are going to have to square both sides. Square root equations, that's the one note I want you to have there, is that you have to square both sides to solve it. For inverse function, and this was in another reporting category, but it's here also, you're going to switch the x and y and solve for y. So inverse function, you switch the x and y and then you solve for y. So that's really the only vocabulary that we have here. So let's look at our problems. Problem number 1, you need to solve the square root of 2x minus 3 plus 5 equals 6. So I'm going to rewrite it because I know it's hard sometimes to see it on the screen. So I need to solve that square root equation, and in order to solve that, I first have to get that square root by itself. So I have to move that plus 5, so I'm going to subtract 5 from both sides. So you get square root of 2x minus 3 equals 1. Now that the square root's by itself, now I can square both sides. I just said that wrong. Now that the square root's by itself, square both sides. So the square and the square root cancel each other, and you're left with 2x minus 3 equals, and then 1 squared, 1 times 1 is 1. And now we just have a normal equation to solve. Add 3 to both sides. So 2x equals 4, divide by 2, and x equals 2. Answer choice B. So you get that square root by itself, and then square both sides. Number 2, the height of a rectangle is given as a function of its diagonal d. And there's a formula here, and again, I know it's going to be hard to see off here, so I'm going to rewrite it. It's h equals the square root of d squared divided by 2 minus 9. All of that is underneath the radical sign. And then minus 3 out here. So that's our function. You need to make sure you write that down. Our question asks us what's the domain of this. So we're going to use our calculator to help us. So I'm going to go to y equals, and I'm going to type that in there. So I have the second and x squared to get the radical, and then I'm going to use parentheses, x squared divided by 2, close those parentheses, minus 9. All of that had to be underneath the radical sign. Now, because I have a newer calculator, I didn't have to put parentheses around everything. It's all of that stuff. If you have an older calculator, you needed a double set of parentheses. So if you have your own that's an older one, like an 83 plus, you needed parentheses around all of that. But because I have a newer one, I don't. So just be careful with that. And then the minus 3, and you can see that that minus 3 is on the outside of the radical now. Now I'm going to hit graph. And look at my graph, there's two parts to it. I've got some x's that are negative and some x's that are on the positive side. So the x's in this case are about the d, they're the diagonals. Now let's think about this logically. Can I have negative lengths for the diagonal, or the negative number of a diagonal, or negative anything about its diagonal? No. So these negatives over here, they don't count. They aren't there. We ignore them. They're like an extraneous solution. They aren't there. Then I'm going to go to my table, and remember I'm only focusing on the positive. I'm going to go to the table and see where my x's start. And I messed with my calculator earlier, so give me a minute to change that. If you look at my table, 0's an error, 1's an error, 2's an error, 3's an error, 4's an error, 5 I have a negative, but can I have a negative for my y value even? Can I have a height that's negative? No. So where does my d really start? It starts at 6. So my domain has to be d is greater than 6. Now, again, if you look at that table and you think about this situation, it's one of those where we have to think about the real world situation. Can it be equal to 6? No, because you're not going to have a height that's 0, because that doesn't make sense. You're not going to have a rectangle with a negative diagonal or a negative height. You're not going to have a rectangle with a 0 height either. So that's why the domain is greater than 6. So I put that in my calculator. I looked at the graph, and I realized, oh, I can't have negative in this case. The equation gives me negatives, but I can't have negatives because of the real world situation. So you've got to think about that as well. Number 3. Number 3 says use the graph to solve the square root of x plus 4 is greater than or equal to 0 and express the solution as an interval. So you have the graph, but you don't have that inequality. So we want that inequality to be greater than or equal to 0. So here's where it's equal to 0. All there. So if we want it greater than 0, it's all the stuff above that line, which means it starts at -4 and goes on to infinity. Answer choice C. If I wanted the square root of x plus 4 to be greater than or equal to 1, so I'm adding to this one, so you need to make sure you write this down. If I add this problem in, the square root of x plus 4 to be greater than or equal to 1, I find where it equals 1 and greater than or equal is above it, and that goes from -3 to infinity. If I wanted square root of x plus 4 to be greater than or equal to 2, I find where it's 2 and then everywhere above it, and that would be from 0. Oops, and I should have brackets around that -3. I hope you caught that. From 0 to infinity. If I wanted it to be the square root of x minus 4 or plus 4 greater than or equal to 3, I come up here to where it's 3 and it hits there, and so it's above 3 from that point on, so from 5 to infinity. So to do those inequalities, you find where it's equal to that number and then go from there. Number 4. Determine the inverse, so inverse of h, for the function h of x equals 3x squared minus 1, where x is greater than or equal to 0. So this is y equals 3x squared minus 1. To find the inverse function, I switch the x and y. So x equals 3y squared minus 1. And now I solve this for y. So I'm going to add 1 to both sides. So x plus 1 equals 3y squared. Then I divide by 3. So I have y squared equals x plus 1 over 3. Now to solve for y, I have to square root and square root. Now I'm going to stop here for a second. Remember it said x had to be greater than or equal to 0? In this case, that means I only want that positive square root. I don't want the negative one, because greater than or equal to 0 is positive. So it has to be answer choice D. So number 5, an athlete's hang time is modeled by the function t equals 1/2 the square root of h, where h represents the height of the jump in feet and t represents the hang time in seconds. if the athlete's hang time is 0.87, that's what you're missing on your paper, 0.87 seconds, what was the height of his jump? So my answers are off the screen for a second, and that's okay. I'm going to go look at my function t equals 1/2 the square root of h. Where does that 0.87 go? Is that the t or is that an h? So h, remember, is the height, t is the time, so that 0.87 is the seconds, so it has to go where t is. And now I have to solve that equation. To solve it, I have to get rid of that 1/2 first. Before you can get rid of a square root, you have to get rid of anything extra that's around it. So I have to get rid of that 1/2. To get rid of that 1/2, I'm going to multiply both sides by 2. So times 2 times 2. 1/2 goes away. And then the 87/100, 0.87 times 2 is 1.74, so 1 74/100. Now, to get rid of that square root, now I can square both sides. So when I square both sides, I get h equals, and then I'm going to square that 1.74, and I get 3.0276. So that has to mean that the answer is C, because we want to just round it. We want an estimate. So remember, everything that I wrote, you should have written on your paper for when I check it.